In previous lessons, we've looked a lot at similarity and congruence in isolation, and now we're going to look at both of them together, but also looking at some more real-world type problems. So the first one we're going to look at is a triangular courtyard. So here is my triangular courtyard. And it says that a walkway runs parallel to the edge of the courtyard. So we've got a walkway here that's parallel to CE. It says that landscapers would like to install a picket fence along the outside of the courtyard with the exception of the walkway. And it says that the fencing comes in 8-foot lengths. So the first thing that we need to do is it tells us that while preparing the sketch of the courtyard, landscapers forgot to label this length right here, so we need to do that. And then we need to figure out how many sections of fencing is it going to take to put up a picket fence along the outside. So if you recall, when we have a parallel line, a line drawn parallel to the base, we have similar triangles, or it divides them. It has similar triangles, but it divides the sides proportionally. So I can set up a ratio. I've got 410 over 164 equals 595 over x, and I can cross multiply 410x equals, let's see, 595 times 164, and I get, let's see, 97580. Divide both sides by 410, and I get 238. So this length right here is 238 feet. And then it asks me how many sections of fencing I need. So first I need the perimeter, so I'm going to add the 238, the 595, the 410, and the 164. And I end up with 1,407 feet. But the fencing comes in 8-foot sections, so I'm going to divide that by 8. I end up with 175 and almost an entire other. So remember that I cannot buy partial sections of fencing, so I'm just going to round that up to 176 sections of fencing. We've done problems similar to this in class, talking about shadows. So we have a meter stick that's casting a shadow, and then a tree that's also casting a shadow. So I've got a meter stick, so that's 1 meter, casting a 65 centimeter shadow, and we'll talk about those two in just a minute. And then I have a tree that is casting a 2.6 meter shadow, and it asks how tall the tree is. So that's what I'm looking for. Here, I'm going to divide this by 100 because in every meter there are 100 centimeters, and we want all of our units to be the same. So I'm going to set up my proportion. I've got 1 over x equals 0.65 over 2.6. Cross multiply, 0.65x equals 2.6 times 1, and then I'm going to divide by 0.65. So 2.6 divided by 0.65, and I get 4. So the tree is 4 meters tall. Here it's asking us to find the distance across a canyon, and it's AR, but it's also labeled as X. So I'm going to set up proportions. Again, I have similar triangles, so I'm going to set it up. I've got 180 over 90 equals, x over 75. Cross multiplying, I have 90x equals 180 times 75, so 13,500. And then I'm going to divide both sides by 90. So I end up with 150 meters. Be the length here. To find the distance across a pond, Rita climbs a 30-foot observation tower on the shore of the pond and locates points A and B so that AC, right here, is perpendicular to CB, and that she then finds the measure of DB to be 12 feet, and it asks what's the measure of AD, and that's labeled as X. So that's what we're looking for here. That's the distance across the pond. So I'm going to set up, I'm going to look at my similar triangles. Remember we talked about the altitude, which is drawn from the vertex perpendicular to the opposite side. But we've got the altitude, and it divides it into some similar triangles. So we've got triangle ABC is similar to triangle ACD. So that's ABC is similar to ACD, and we're always labeling that right angle last. And then triangle CBD as well. So I'm going to set up that proportion. I've got 12 over 30 equals 30 over x. Remember that they both have this side in it, so that's why you see 30 twice. And I'm going to cross multiply and then divide both sides by 12. 900 divided by 12 is 75. So my answer for x, or for AD, is 75 feet. Alright, the last problem we're going to look at, it says to estimate the height of an overhang, the surveyor positions herself so that her line of sight to the top of an overhang and her line of sight to the bottom form a right angle. So here is the person standing right here. What is the height of the overhang to the nearest tenth of a meter? So that's what we're looking for. And again, we have some similar triangles. We've got triangle, what's that? Say ABC. So this large triangle, and I named the right angle last, is similar to triangle ACD. ACD, naming that right angle last, is also similar to triangle CBD. CBD. So I'm going to set up my proportion. I've got 1.75 over 8.5 equals 8.5 over x. Now it may be helpful for you to pull out those similar triangles that we're talking about. So we've got this large triangle BDC, and it's 8.5. And then we've also got this smaller triangle here, and let's see, that's DCA, and this is 1.75, and this is 8.5. So now you can kind of see we've got 1.75 over 8.5, 8.5 over x. So that's where those are coming from. If I cross multiply, I have 1.75x. 8.5 times 8.5, it gives me 72.25. Divide both sides, and I end up with 41.3, and that's this length right here. And so the overhang itself would be all of this, so I need to take the 41.3 and add 1.75, and I end up, when I add those two, getting 43.05. But again, it says to the nearest tenth of a meter, so I need to round this to 43.1 meters.